Enough, settle down. I don't think so. You are even interested in having a decent kind of break. Creating unnecessary nuisance when there is class going on in the next room. I know, Pratik, it must be somebody from you because you were the ones who had come up with that. Don't even try to behave in a
No, ma'am, I was in the
All right.
Yes, ma'am. Pratik was only doing.
Let's start with the next part, and I think we will be able to finish this chapter today. Okay, and hopefully you go back home, try to solve as many questions. Do not create a backlog for future that you will do the practice part later. Don't do it. All right. Let's go to the now comes to major parts. So we have understood concave, convex lenses. Where are we applying them? And we have seen power also. Hopefully you won't go wrong in calculation of power. It is pretty straightforward. The only part that where you can go wrong is this, not converting into meters. So please remember, it's important. And we are moving to last two important experiments which you will be performing, I believe, in your schools, provided your schools do that. They are very important experiments. So understanding the experiment before performing it is important. Pay attention and please lose that habit of, I don't know, you're commenting, passerby comment or whatever, or you're talking to yourself, whatever it is. It is not a good way. And let's now see once we have seen magnification, right? So can you tell me what kind of lens do we use for magnification? Convex or concave? Convex lens. And for magnification part, where is the object kept when I get a magnified image for convex lens? Where do I keep my object? If I'm getting magnified image, that means I'm keeping object at some places, right? Or at all places it gives magnified image?
Between F and F and O. Between F and O.
Between
F and F.
F and O, if I keep my object,
Although it will be
it gives me, yes, although it is virtual, it will give me magnified image. So why I am redrawing this, because this is the next part, which is simple microscope, or not compound microscope, this is simple microscope, or magnifying glass. So instead of, if your question says draw ray diagram for magnifying glass, you should be clear in your head that for magnifying glass, I have to use a convex lens and I have to show my object between F and O.
Between F and O.
Will you get magnified image for that?
Yes, later over here.
No. Between?
F and O.
What kind of image? Real or virtual?
Real and
Is this real? We are not talking about, they are talking about something else. All right, I'll answer that question of yours. So, you are
slide projector.
I understood what you are. Now think of that when you are using that thing of magnifying glass, जब लेते हो आपको object यहाँ रखा हुआ है और आपको कौन सा केस क्या है?
Between F and O.
Between F and 2F के पर यहाँ object है, यहाँ मेरा लेंस है, इमेज कहाँ फॉर्म होगा? कहीं यहाँ पे फॉर्म होगा, ठीक है? आप जब मैग्नीफाइंग लेंस यूज करते हो, आप यहाँ पे एक और एक स्क्रीन रखते हो जहाँ पे चेक करते हो, आप यहीं से देखते हो, वहीं से magnified image देखते हो. What is your purpose of magnifying glass? Do you keep on the screen and magnifying glass? Certainly not. But you are definitely looking for enlarged image, right? So which one will you put? That one? Where you get, I agree, you get a magnified image, but it is real. It is real. This is the not real case. That is why I'm telling you, when you are getting a question where they are asking you to draw magnifying glass, you should be clear in your head, not just write any magnified image wala part, that the one that he is saying, the real magnified one. We are talking about this case where object is kept between focus and optical center. ठीक है? And I get a magnified image. And the same thing is used by, आपको पता, आपने अगर शायद मूवी में देखा होगा, हीरे ज्वारी वाले जो लोग होते हैं वो सिंपल माइक्रोस्कोप होता है, एक ही लेंस होता है और वहां नीचे हीरा रखकर they observe. So that is the other name of magnifying glass is simple microscope. ठीक है? I hope this is clear to you. I am not asking you to draw this diagram again because you have drawn, but that goes as homework. So please draw simple microscope magnifying this case. So write that topic, put draw as homework, and you will be drawing this at home with a nicely ray diagram. I am requesting a nicely ray diagram. आपका please write label objects properly, O dash, and label image also. I have seen not labeled object and images. Show direction of rays before refraction and after refraction. Yes, I'm just raising some important points in your diagram. Is this clear?
Yes, ma'am.
So now let's go to two important experiments. Please move from that position and sit here quickly. All right. So this is your homework point. You already know this point, but I'm erasing this now. Let's move to the two important experiments. In this experiment, all right. So in this case, your aim is, so we have two experiments. The first experiment, what is the purpose of our experiment? We will be given one lens, and what kind of lens is it? It is convex lens. Okay, and you will be given this lens and you will be asked to find its focal length. आपको क्या करना है? Experiment करके इसका focal length ढूंढना है. ठीक है? How will you find focal length of this image? So of course आपको अगर focal length ढूंढना है तो आपको object का कहीं image form करना पड़ेगा. ठीक है? तो आपको एक object भी चाहिए होगा. In this case, in this experiment, this is very important. We will be using a distant object. Distant object मतलब object का कहाँ है? काफी दूर है. ठीक है? Yes, maybe you have done it in your school, but I don't think so others are aware about this. All right, so now object is kept very far, and we know when object is very far, मान लीजिए एकदम infinity है, तो image कहाँ form होता है? Focus. ठीक है? So of course in reality, since I am doing an experiment, I can't keep my object at infinity. ठीक है? But I can keep it very far, as much far as I can. I will try to keep. So what do we do in this case? We take a far object which can be a building or a tree or anything. सबकी विंडो से कोई अगर बहुत बात दूर थोड़ी बिल्डिंग है या ट्री है तो आप उसको ऑब्जेक्ट की तरह यूज करोगे. आप आपके लेंस को ऐसे अरेंज करोगे कि ट्री से सारी जो रेस आ रही है वो दिस लेंस से हिट हो. ठीक है? एंड what do I know? That I can capture image of this tree. ठीक है? On a screen, right? Because what is this lens? Convex lens. And if object is very far, तो rays जब hit होगी तो कैसी होगी? Parallel होगी. Let me just draw only two rays. ठीक है? So, and after hitting this parallel rays will meet where? So they will meet at focus. Okay? So I know if my object is very far, the rays are coming, ठीक है, parallel hit हुए, and then finally जाकर वो कहाँ यहाँ मिलेंगे. और मैंने यहाँ पे जो screen रख दी, it can be anything, a piece of paper. If I do not have piece of paper, even I can use a wall. ठीक है? So I can use wall. I can use this window. I keep my lens over here. Of course, ये एक्सपेरिमेंट सुबह करोगे क्योंकि बाहर का ऑब्जेक्ट से लाइट भी तो आनी चाहिए अंदर. ठीक है? बाहर दूर का ऑब्जेक्ट. ठीक है? सो बाहर से जो रेज आ रही है, ठीक है, ये मेरा जो लेंस है, यहाँ इमेज फॉर्म होगी. ठीक है? कब इमेज फॉर्म होगी? I have to actually move my lens such that I get a clear image on this wall. Once I get clear image, that means I have placed my lens at such point where the distance between screen and my lens is focal length, because हमें पता है दूर का ऑब्जेक्ट का इमेज कहाँ बनता है? फोकस पे. ठीक है? तो ये फोकल लेंथ होगा तभी यहाँ क्लियर दिखेगी, अदरवाइज तो क्या होगा? या तो इमेज डिमिनिश कभी ब्लर हो गया तो होगी. ठीक है? डिपेंडिंग अपॉन द एरिया. आई होप दिस इज क्लियर. सो व्हाट वी रिक्वायर, I will take. Thank you. So what is important over here is I need two things. One is object which is far. I can't use him as object because he will be very close to lens, so I can't use him. Okay? So I will have to use something which is far, so that at least I can use this principle that when object is very far away, image is formed at focus. Okay? So let's just say my image is formed here and I have placed my screen over here. Okay? So this is screen. This screen can be anything, wall or paper, anything. Okay? I have, this is, can I get, okay, oh yeah, no, there's one. What is important for me is the measurement between screen and the lens, right? Because I need focal and that is what they have asked me to find. So I will place ruler such that wall के जो point है वहां पे क्या label होना चाहिए? 0 सेंटीमीटर. ठीक है? फिर ये 1 सेंटीमीटर, ये 2 सेंटीमीटर, ये 3 सेंटीमीटर, ये 4 सेंटीमीटर, ये 5, ये 6, 7. Can you tell me what is focal length of my lens in this case?
4 centimeter.
Clearly 4 centimeter, because lens is how much far from the screen, not the object. It is 4 centimeter. Okay. So how will this look in case of a diagram if you have to draw properly? So this is tree. This is my lens. Okay. You have to draw convex lens because we are finding focal length of convex lens. What kind of image will I get on the screen which is kept here? I will get real image. So real image is inverted. All right. So whatever I'm trying to see on my wall would be what? Inverted image of the object that is there outside. Is this clear?
Yes.
Okay. Now quickly draw simple diagram. And if you are asked in examination to draw a diagram, which ray diagram will you choose for this? Oh, okay. If I ask you, a child performs experiment to find focal length of convex lens using distant object. Which principle is he using? So which principle is this child using? He is using the principle. No. He is using. Okay, which? The question is, a child is determining focal length of a convex lens using distant object. Okay? Okay. Which principle will he use to find the focal length of the distance object? Which principle did I use? I am using which rays?
Some part of the
That is the principle. Yes. the rays which come from infinity meet at ठीक है. So this is the principle he is using. He is keeping far object so that he can use the principle of rays coming from infinity meet at focus. I hope you have understood.
Yes,
ठीक है. Please draw the ray diagram. Please draw one simple diagram to understand what are we finding in terms of the screen, what kind of image is captured in screen, and you can expect some questions. This will be virtual or direct?
Real and inverted.
Where am I capturing it? On screen. Screen पे कैसे image capture होती है? Real और real हमेशा कैसे होती है? तो मैं यहाँ ऐसे draw कर दूँ कि आपको तो question आपने ऐसे draw कर दिया, आपके marks आपको मिलेंगे? नहीं।
वो मेरा है सीधा.
ठीक है. So please draw it properly. ठीक है. And finish this and write the principle.
वैसा उल्टा प्रभाव भी उल्टा दिखेगा.
What is the principle?
प्रतिको उल्टा रखने के लिए.
Ma'am, we have to make the ray diagram.
You have to draw the ray diagram. ठीक है. And you have to write the principle. What is the principle we just discussed?
Principle
Rays of light coming from infinity
and passing through focus.
and bracket में आप लिख दोगे distant object because आप उसे infinity समझ रहे हो. Distant object converge. Why I am writing converge? Because which lens are we using? Convex lens. Converge and meet at focus in convex lens and meet at focus of convex lens. Then we'll discuss the second experiment. Okay, this is pretty easy experiment to do even in school. But the second experiment is very tough, so pay attention for that. Hopefully your school will not ask you to perform that in examination. Hopefully. But if it comes, then if you get the skills right, it should not be. Okay. अच्छा, अब ये स्क्रीन है, ठीक है, ये स्क्रीन है. यहाँ इन्वर्टेड इमेज बनाना मुश्किल है, ये सिंगल 2D पिक्चर है ना बेटा, इसलिए मैंने वहाँ ऐसे बनाया. ठीक है. तो यहाँ आप इसलिए लिख दीजिए कि ये स्क्रीन है, ठीक है. इसको थिक बना दीजिए ताकि आपको समझ आ जाए डायग्राम में कि ये स्क्रीन है. ऑलराइट. Which is the other one next to it?
Yes.
Alright, is it done? Everyone? Both of you are done? Pratik?
Namaste.
Don't use it. Who asked you to move from? Your dreams are being associated or move from this place.
No, ma'am. Then he was moving. Camera check कर.
Pratik, stop. Move your work. Lady and I will make it. If they can ask you to, in simple words, they can answer it all that. आपको इसमें एम लिखना है, फिर से प्रिंसिपल लिखना है, और बाद में वर्ड्स का बोलोगे. ठीक है, एक्सपेक्टिंग आप क्या लिखोगे? ओके, सो शी इज आस्किंग where did the marker go? Okay, so she is asking, will you be asked to write this experiment in words? Mostly no, but it is not unlikely. अगर आ गया तो भी आपको सेम चीज वर्ड्स में लिखना है. आपका डायग्राम काफी सफिशिएंट होगा समझाने के लिए. आप एक चीज ऐड करिए कि आपको क्या है, यहाँ पे रूलर भी रखना है, बिकॉज रूलर से ही तो मेजरमेंट हो रही है. लेबलिंग में ही डाल दीजिए तो इजी हो जाएगा, बिकॉज हमें मेजरमेंट करना है और मेजरमेंट के लिए आप रूलर यूज करोगे. आइडिया ये अब मीटर रूलर 15 सेंटीमीटर वाला रूलर नहीं. I was after convergence direction. Why is it diverging? पहले से क्यों bend होने लग रही है? इसके अंदर आने के बाद bend होता है. All right, is it done? Almost. Then comes the next experiment. So we have only 2 experiments, and after that we will be finishing this chapter.
One experiment will carry out.
It depends mostly for your practicals. In this, they won't ask you in detail, but if you're still asked, this one can be only asked for 2 marks because it's very short.
But it can ask us picture study in section.
Student is asking you picture study. I drew this picture and I asked you one question. What is focal length of this lens? What did you say?
4 centimeters.
How much marks do you expect for this?
1 mark.
If you get 1 mark, it's great. Yes, otherwise half marks. Half marks for this, half marks for the rest. All right, is it done?
Yeah.
No more.
Yes, I'm done.
Is it done? See, since you have written it reads as focus, so please. Okay, everyone, I have missed one important point. I asked everybody via answer what is the focal length. You all told me it is 4 centimeters, right? So please show that in the diagram also that this distance is how much? This is the focal length. Please show that as well. So basically your diagram is telling you everything. Okay, girls, did you add this point? All right. Now let's move to the second experiment, which is a bit tricky to understand and perform. But once you know the tricks behind that, it should not be a problem. It should be interesting actually, because this will be the first time you will be playing with parallax. What? I like this. How much time do we have? 30 minutes. All right.
35 minutes. 40
Accurate है, exact word है क्या है?
Determination of exact.
Exactly है ना?
Exact focal length and auxiliary.
Exactly.
Plain mirror method है ना?
Auxiliary mirror method. Next page में बातें auxiliary mirror method. Only है जो बचेगा.
Now pay attention for this one because this is new. So what we use in this case is, let's just say there is a mirror cap. ठीक है, यहाँ mirror है और mirror अच्छा Okay, if you are able, I'll just hold this over here. So there is mirror at the surface, and I'm drawing 2D picture of that. So there is mirror at the bottom. मिरर के ऊपर आपने आपका लेंस रख दिया है. कौन सा लेंस हम यूज कर रहे हैं? कॉन्वेक्स. सो लेंस रख दिया इसके ऊपर. आई एम ड्रॉइंग लेंस.
And this is on which page in the diagram?
What is the page number? Just share with us. 130.
130.
So there is 130. So there is mirror below. There is lens kept over this. ठीक है? And lens के above हमने क्या रखा है? एक पिन रखा है. ठीक है? If there is no lens and there is mirror and I'm keeping my pin tip like this, आप ऑब्जर्व करोगे इसका इमेज कहाँ पे नजर आएगा आपको? इमेज मिरर के अंदर आएगा. ठीक है? मिरर यहाँ है. So if this is 2 centimeter away, तो इमेज का होगा 2 centimeter behind the mirror. ठीक है? Since I am using this lens, ठीक है? And convex lens क्या करता है? रे को कन्वर्ट करता है. ठीक है? और अगर कुछ रे फोकस से आ रही है तो उसे क्या बना देगा? पैरेलल कर देगा. ठीक है? What happens is an interesting case happens where this is the pin and इस pin की image हमको इसके opposite मिलती है. So if I can show you, if this black is object and नीचे हमने ये हमारा जो भी लेंस सेटअप है, हमारा मिरर है, मिरर के ऊपर लेंस है. मान लीजिए अगर ये इमेज, ये ऑब्जेक्ट है, इसका इमेज मुझे कहाँ नजर आएगा? इसके एग्जैक्ट ऑपोजिट नजर आएगा. Are you getting what happens? So let's just see what happens in the diagram. So if I am placing an object, so this is a stand. Draw stand properly. There is a stand. Can I get scale? Can I get one ruler if somebody is giving? I'll give the bigger one. So pay attention. Setup arrangement is very much crucial. So if you go wrong with setup arrangement, आपके स्कूल में भी आपको ये परफॉर्म करने में दिक्कत आएगी. What is the first thing? आपको ऑब्जेक्ट ऐसे अरेंज करना है such that आपका ये जो टिप है, it should be exactly above optical center, properly aligned. So what is the tip? This tip is a pin जिसका ये sharp point है. ठीक है? ये कोई pin है. So let's say this is that pin and I have arranged it. So what was the first thing that we saw? We have to arrange this arrangement such that this pin is okay. This is very thin pin that we use. So if you can draw very thin pin, that would be nice. And this is clamped to our stand. What will I see? I will observe an image, and that image is exactly opposite. And so if you look at page 130, you can see the diagram. So this is how you see your image. I'll try my best to replicate it properly. For the compliment coming from somebody who is otherwise not like this. All right, now pay attention. How do we get this diagram? Why are we getting image over here is a crucial point that you should ask yourself. आपको पहले ये सेटअप अरेंज करना है. आपने लेंस रख दिया मिरर के ऊपर. आप ये जो आपका पिन है पहले तो इसे ऊपर नीचे मूव करते हो, ठीक है, और एक पॉइंट पे अरेंज करते हो जहां पे आपको इमेज विदाउट पैरेलैक्स एरर, हम देखेंगे क्या है वो विदाउट पैरेलैक्स एरर आता है. आपको वो जगह पे इसे क्लैंप कर देना है, ठीक है. व्हाट इज पैरेलैक्स एरर? सो आप जब ये अरेंज कर रहे हैं ना, सो ये जो हमारी पिन थी, कहाँ गया हमारा दूसरा मार्कर? सो फर्स्ट थिंग व्हाटएवर इज द इमेज फॉर्मेशन, आपको ये टॉप से देखना है. एंड आप जैसे इस साइड में जाएंगे तो आपका इमेज दोनों मूव होना चाहिए. एंड अगर आप ये साइड में गए या ये साइड में गए तो आपका ऑब्जेक्ट और इमेज दोनों मूव होगा विदाउट पैरेलैक्स एरर. इफ वन ऑफ देम शिफ्ट्स एंड इमेज उधर की उधर ही है या ऐसे शिफ्ट होगा, दैट मींस देयर इज एरर. बट इफ बोथ ऑफ देम आर विदाउट पैरेलैक्स एरर, आपने प्रॉपर अरेंजमेंट कर लिया, दैट मींस इफ यू मूव देन ऑब्जेक्ट एंड इमेज बोथ विल मूव. सो इफ यू कैन, I'll repeat so that you know you have understood. Can you go to page 130? Can you go to page 130? Can you read the second point? Adjust the height of the pen till it has no parallax with its inverted image as seen from vertically above the pen. To check parallax, keep eye vertically above. So आपने ये आपकी आंखें vertically above रखी है object और image के. And what will you observe? And of course nearly 25 centimeter because हमारी आंखों का minimum distance का vision होता है. Vision का minimum distance होता है. And what does it say? Yes, if the tip of the pen and its image shift together, there is no parallax error. So if you are moving, and if your image and object both are moving, that means there is no parallax error. But if you move your head from here to here and instead only one moves, that means there is parallax error. That means both of them have been arranged such that they move together. Just you will understand when you are performing the experiment, and I'll try to get a video of this in case it is possible. It is beautiful experiment. Trust me, if you perform this, I will try. I think if not this, at least I can tell you what parallax error is. What is this error? We are determining the focal length using auxiliary plane mirror method. So there is a plane mirror. ये जो है ये plane mirror है. ये जो है कौन सा लेंस है? ठीक है. और ये क्या है? पिन है. पिन. ठीक है. All right. So why is this? Now answering the question, why is this inverted image formed here? That's very interesting to see. So we arrange it such that we stop at one point where there is no parallax error, and what happens is this position is such that it is actually at focus point. Which point? Focus point. So you know when rays come from focus point, so let's say this is tip and it is hitting the, which lens is this? Convex lens. So let's say two rays are hitting like this. What will happen after refraction? Since it is coming from focus, after refraction it will become what? Parallel, right? Do you remember that? And on what is it hitting? It is hitting plane mirror. Alright. Enough of the discussion. This is the most important one. I'm here for the video now. Finish the video now. No, I'm saying I look for the videos. It's not this not available online, but I have few of them who can work for me and they send me the videos. I try my best. I can't but commit. Anyway, so you will be doing it in school. They give you this example. All right. So this was the major point where since these rays are coming from focus, post refraction they become parallel, right? And you know when it hits parallel mirror तो सीधा अगर normally hit होता है तो it will bounce back, and since it is bouncing back the same path, वो फिर से वही path में जा रहा है और फिर से ray यहीं पे जाकर क्या हो रहा है? मिल रहा है. ठीक है. So that means ये टिप का इमेज कहाँ बन रहा है? वहीं पे बन रहा है. अब यहाँ से मान लीजिए कोई ray आएगी, उसका इमेज कहाँ बन as well as mirror, because mirror अगर ये लेंस होता तो इमेज कहाँ फॉर्म होनी थी, पीछे, बट ये मिरर ने क्या कर दिया, उसका पीछे बनाने की बजाय वही इन्वर्टेड इमेज को यहाँ बना दिया. आई होप यू हैव अंडरस्टूड द लॉजिक बिहाइंड द इम्पोर्टेंस ऑफ मिरर. ठीक है. एंड हाउ now you know that if I have got a position where this pin and this image, so this object and this image are without parallax error, if this is the case, then this distance, this whole distance is not this whole distance, because इसमें क्या होता है, ये extra position, extra है, right? हमारा focal length का होता है distance between optical center and the tip. ठीक है. So to remove that error, I don't think so you have formula, but still write the formula. You don't know. So they're using x and y. X plus y. No, they are using this distance as x. I don't think so you have to learn the formula, but still know it as of today. This distance is known as x, and this distance from mirror is known as y. So I have answered your question. Why are they not taking y distance? Because that y distance is distance between image and the mirror. That cannot be focal length because image and optical center चाहिए. ठीक है? So how do we compensate that? We find this distance, and I think no, we have the formula. No, I'm not sure if you. Okay. So they are not taking this distance. They are taking up till this. So they find this y, they find x, and इन दोनों का average निकाल लेंगे तो आपको ये वाला distance मिल जाएगा, distance from this point and this point. Okay, and I don't think so you have to worry about the formula. It will not be used, but still just write it. So focal length is given by x plus y by 2. Why not directly x? Because x represents distance between this two, and y represents distance between mirror and the image, and we want distance from optical center and the object also. Okay, that is why we use this x plus y formula. Please, this is the last experiment. Write it down. Draw proper ray diagram. This is very important. And we will solve one last numerical and end this chapter. Is it done? Great. The ones who are done can take the numerical now. All right. Oh, great. Directions are important. Directions are directions are very good. Please do not miss great directions. These are important. Is it done? Great directions. Is there any? No.
I know, but this
All right, if this is finished, you can solve the numerical. Can I get volume so that I can give? All right, can you go to page number 95? Can you go to page number 95?
Yes, ma'am. On.
Question number 30. Sorry, 40.
Can you write?
Page 95, question 14. Whose book is this?
Question number
13. No, I said question number 14. Is it concave length? 14.
ये नीले
Why are you enough? Enough. I want your place. Why are you getting into Please solve question. Off your volume.
क्या मेरे पास नहीं है वॉल्यूम
She's shouting on me.
I expect correct answer from everyone for this. We have solved good number of numericals to understand where we can go wrong. So please give me correct answer. Prateek, solve this question.
Yes, ma'am.
No, I can't find the volume. Is anyone have what is your Harshita? Harshita, have you written your name? Okay, please check if you are having Harshita's volume with you. Please check. Please check. If you do not have, that's all right. If somebody is having it, please return it to her. Harshita, and then you can just refer this. Can you share it with the question? What about you? You have the volume, right? Please solve.
Mom, it is same.
I know question would be same. I am expecting correct answer.
Ma'am, the answer is equals to 10.
Yes, ma'am, even I got V is equal to 10 and magnification as half.
Ma'am, I got 10 centimeter.
So you are getting V as positive 10. That means it is a real input.
No, V is negative 10.
Oh, sorry, negative.
So if V is negative, then it can be correct. If it is positive, it is not. Swastika is also getting minus 10. So we are
I
hoping
just forgot to put the sign.
there is no.
Yes.
All right. So two of them have got minus 10 as answer.
minus 10
Minus 10. Minus 10. So let's see. Concave lens is used. It has been said. What is the focal length given?
20 centimeter.
20 centimeter. Will I write plus 20 or minus 20?
Minus.
It is concave lens, so please don't go wrong. What is the other information? Where is the object here?
In front of convex lens.
I know object will be kept in front of, but where? Concave, no? In front of.
20
Where?
centimeter.
20. Sure, it is kept at 20 centimeter.
Yes, ma'am.
Yes, ma'am. What distance is over in that? So this is minus because object is always negative. What are they asking us to find? B, right? So let's use the formula 1 by V minus 1 by U is equal to 1 by F. So 1 by V is to be found minus 20
Magnification is 0.5.
and 1 by V is equal to
1 by minus 20 minus 1 by 20.
so this minus minus becomes plus. When it goes on this side again, it becomes minus. So what I have with me is 1 by b is equal to
minus 10
minus 1 by 20. So 1 by b is equal to minus 2. So therefore b is equal to 20 by 2 with a minus sign. So even I am getting minus 10 as the answer.
And magnification is 0.5.
They are asking magnification as well. So let's find magnification. Magnification is b by u, which is equal to minus 10 by minus 20, which is equal to
1 by 2.
0.5 or 1 by 2. And to positive, that means we are getting virtual units. All right.
Ma'am, it's very easy.
Yes. I hope it's very easy.
highly diminished.
Yes, because it's half of the
Highly diminished.
up to 0.001. All right, now towards the end, like I said, let's do definitions and you can leave with that. All right, let's.
Ma'am, we can leave.
I said definition. You hear that also because we are not.
Which definition?
I am about to tell you आपको क्या पढ़ना है फिर जाना.
बोल दो मैं दो
पूरे
definition
चैप्टर
बोल के
का पूरे चैप्टर मैं बता रही हूँ आपको फिलहाल.
Principal axis.
First is principal axis भी बता देंगे. That's the easiest one.
It's a line
Go to
joining
page 105. Page 105.
it's a line joining to center of curvature.
So I got definition of principal axis. The first sentence is the line which joins the center of curvature
Up to different surfaces.
up to different surfaces of that. Page 105, 105, 105, whichever you understand. The second one that you have to say is page 106. Now pay attention for this. This is a bit tricky one. Page 106 पे जाइए. Optical center थोड़ा tricky है. आप optical center में दो definitions देखेंगे. Is everybody with me for this?
Yes,
Look at the first optical center definition. It is a point on the principal axis of the lens such that ray of light passing through this point emerges parallel to its direction of incidence. अब हमने क्या देखा था? अगर आपको याद है, ऑप्टिकल सेंटर हम किसे कहते थे?
It is a point.
It is the point on the lens जहाँ पे अगर किसी रे ने हिट कर दिया तो goes without deviation. But the problem is ये हमने क्या देखा था? हमें कब करते हैं? In reality तो हमें पता है कि रिफ्रैक्शन दो जगह पे होता है, राइट? एक ये पॉइंट पे बेंड होता है और एक यहाँ पे होता है, ठीक है? So in reality what happens is there is some bending जिसकी वजह से कुछ lateral displacement होता है. But the thing is since we are using very thin lens, जब बहुत thin lens use करते हैं, so अगर deviation इतना कम होता है कि हम सीधा की सीधा वो optical center की direction में ही जाते हैं. Now pay attention. If you get definition for examination, I'm saying if you get defined optical center of thin lens, then you can directly say optical center is the point through which the ray which is incident passes without any deviation.
Undeviated.
But अगर आपको simply बोला है optical center of a lens, तो आप ये जो first definition है, it is the point on principal axis of the lens. Page 106.
What's the number?
First sentence जो है पूरा आपको वो करते हैं. But आप ये blue part नीचे देख रहे हो? Optical center of thin lens. तो वो thin lens का अगर आया है तो आप वैसे बताइए. ठीक है, दोनों same.
अभी आप जो
हाँ, अभी मैं कौन सा पूछा? अभी मैं दोनों में से कुछ भी पूछा. So आपके पास अभी कितने? 3. I have only asked you 3 definitions. I think you can give me that.
Ma'am, you can ask first focal point also.
फोकल प्लेन इंपॉर्टेंट है. आप फोकल प्लेन एक्सपेक्ट कर सकते हो डेफिनेशन के लिए. व्हाट इज फोकल प्लेन? आपको याद है?
Oh, plane normal to the principal axis.
Exactly. What is this?
Principal axis.
Principal axis.
Ideally focus कहाँ होता है? प्रिंसिपल एक्सिस, राइट? ये कब फोकस कहा जाता है? जब यहाँ से पैरेलल रेज ऐसे आ रही है तो सारी कहाँ मीट करती है? एट दिस फोकस पॉइंट. बट जस्ट इमेजिन ऐसे आने की बजाय अगर रेस if rays were hitting at this angle ऐसे parallel आ रहे थे ठीक है will this go and meet at this focus
No, ma'am.
ठीक है this cannot happen so where will this rays meet this will also meet somewhere but not at focus but somewhere below focus
Yes, ma'am.
and we can call this on the focal plane पे कहीं तो पाऊंगा so basically ये अगर focal plane है आपका which is perpendicular to the principal axis so आपके कोई भी plane में कहीं पे भी कोई focus point f dash होगा so ये सारी rays जो है वहाँ पे converge होकर मिलेगी ठीक है हम देख सकते हैं so फोकल प्लेन को प्लीज इग्नोर मत करिएगा ठीक है आज अभी के लिए आप मुझे कोई भी तीन लर्न करते हैं
Normal to the.
मैं आपको प्रिंसिपल एक्सिस का ऑप्शन दे रही हूँ ऑप्टिकल सेंटर का ऑप्शन दे रही हूँ प्रिंसिपल फोकाई का ऑप्शन दे रही हूँ एंड फोकल प्लेन का ऑप्शन दे रही हूँ आप इनमें से कोई भी दो बता दीजिए और जाइए
ऑप्टिकल सेंटर को दोनों को लगाएंगे ये प्रिंसिपल
प्रिंसिपल एक्सिस ऑप्टिकल सेंटर प्रिंसिपल फोकाई बेसिकली प्रिंसिपल फोकस एंड फोकल प्लेन
चमन प्रिंसिपल फोकल
आज तो सब पूरा
Now, once you are done, make sure you maintain silence for others. And I am, Pratik, you are done. ठीक है, we will not disturb others. अब बाहर आइए, मुझे बताइए अंदर।
दो बोला.
Go means you have to open or wait here and discover.
Now I will sit here.
Better